In section 6.2, we are factoring trinomials of the form x squared plus bx plus c. Now what that means is, given a trinomial that has a square term, a linear term, and a constant, for instance, if we look at x squared plus 4x plus 3 as it is listed, the first example that I give you here, it has a coefficient of the square term that is a 1. Notice we don't see a coefficient, so we understand the coefficient to be 1, where I just wrote it in red. Look at the next one. X squared minus 8x plus 15 has a leading coefficient of 1. The next one, r squared minus r minus 42, has a leading coefficient of 1. So I'm telling you this because when your polynomial has, or trinomial has a leading coefficient, meaning the coefficient of the square term, when that is a 1, there's a certain way you have to factor it. And it's the easiest method of factoring for trinomials. Now, let's review right quick and recall what factoring means. Factoring means to write as a product. In other words, if I have 8x plus 12 and I ask you to factor it, it means factor out the GCF, which is 4, and you'll be left with 2x plus 3. And this is a product. It's a product because you're multiplying now 4 times 2x plus 3. Okay? So it's a product and it is fully factored. Okay? Now, I want to show you something here. Let's go back a second to chapter 5. If I give you these two binomials and ask you to multiply them, remember you can FOIL them, right? Now if you FOIL them, FOIL gives you what? The first would be x squared. The outer would be x times 5, or 5x. The inner would be, doggone it, the inner would be 2 times x. And the last would be 2 times 5, which is 10. Then you would combine the middle two terms to get x squared plus 7x plus 10. Now, I want you to look very closely. I'm going to erase these lines over here. Look very closely at the trinomial that we got right here. Where did the x squared come from in this trinomial? It came from multiplying this x and this x, didn't it? It came from multiplying those. So now, where did the 10 come from in our trinomial? The 10 came from multiplying the 2 and the 5. Okay, so the x squared came from multiplying the two x's. The 10 came from multiplying the 2 and the 5. But multiplying 2 and 5 gives you 10. But look at what happens when you add 2 and 5. When you add 2 and 5, you get 7. But 7 is the coefficient of the middle term. So what happens is, every time you FOIL and you come up with a trinomial like this, you can look at a trinomial and work your way backwards and factor it into the two binomials that would have been multiplied to give you that trinomial. So what you look for is, you look at your x squared and ask yourself, where could this have come from? You look at the 10 and say, 10 comes from multiplying two numbers. The 7 comes from adding the same two numbers that will multiply to give 10. So what we're going to do is look at our trinomial, and we're going to ask ourselves, what two numbers multiply to give you 10 and also add to give you 7? That's what we're going to do. We're going to look for those numbers, and it's going to cause us to break up our factors into two binomials. And watch what I do on the next slide. All right, so look at what we have. A helpful hint says, since multiplication is commutative, the factored form of a trinomial, x squared plus 7x plus 10 can be written as either x plus 2 times x plus 5 or x plus 5 times x plus 2. You'll see that in practice in a few minutes. But the question that we want to ask ourselves when we're factoring, if you are number one, if you're given a trinomial and the coefficient of the x squared term is a 1, you know you can start factoring quickly by, number one, observing that we have, look at x squared plus 9x plus 20. Look at it. The coefficient of the x squared term is 1. So what we do is immediately create our two binomials with our parentheses. Then we know that x squared came from multiplying an x and an x. So we fill in the x and the x. Now the key is finding out what two numbers multiply to positive 20, but the same numbers have to add to positive 9. Look at the coefficient of the x term, 9. Look at the constant, 20. So you have to do a little bit of thinking here. You have to ask yourself, what two numbers multiply to 20 but add to 9? So there's a few ways to get 20. You can get 20 by multiplying 20 times 1, 2 times 10, 4 times 5. All of those ways multiply to give you 20. If all of those numbers are positive, they will give you a 20 if you multiply. But listen to 4 times 5. 4 times 5. So if we have 1 times 20, 2 times 10, 4 times 5, all of that gives you 20. But when you add them, only one set of them will give you 9. So the two numbers that we're looking for is a positive 4 and a positive 5, because they multiply to 20 and add to 9. And that's what we're going to be doing, except that some problems will require a little bit more analyzing because the signs will be different. But you have just factored the trinomial, and you know it's going to work out right, because if you FOIL it, what do you get? If you FOIL it, you get x squared plus 5x plus 4x plus 20, right? Which simplifies to x squared plus 9x plus 20. So the key is to ask yourself the right question when you're working a problem. What two numbers multiply to the constant, considering the sign of the constant, and what has to be the same two numbers that add to the middle coefficient? All right, so let's go and let's factor some. All right, first question. Is the leading coefficient here a 1 for the first problem? Is it 1? X squared. It has a leading coefficient of 1. So we know that we can factor, there is no greatest common factor to factor out, because the greatest common factor here for all three of those terms is a 1. So what two terms multiply to x squared? X and x. We know that. That's a given. Now look at 6 and look at 5. They're both positive. So think about it carefully. What two numbers multiply to 6, a positive 6, but add to a positive 5? Think about it. They have to multiply to a positive 6, and they also have to add to a positive 5. Positive 5. Think about it, positive. So that would be 2 and 3. Positive 2 and positive 3. They both multiply to 6, and they add up to 5. Now somebody's thinking, oh, 6 and 1. 6 and 1 could have done it. But 6 and 1 don't add to 5. You see? They have to both be positive, but 6 and 1 don't add to 5. So that won't work. There's only one right way of factoring, and this is it. So x plus 2 times x plus 3. Now, what was mentioned before is that you could have written the x plus 3 first times the x plus 2 because of the commutative property. So either way is correct. Look at the next one. X squared minus 14x plus 33. Well, we have the leading coefficient is 1, so we can just start factoring now. We know that x squared comes from x and x. Now look at 33. 33 is positive, but the middle coefficient is a negative 14. So you have to carefully think about what two numbers multiply to a positive 33 but add to a negative 14. Now, in order for two numbers to multiply to a positive 13, either both numbers have to be positive or both numbers have to be negative. Okay? If you multiply, say, 3 and 11, a positive 3 and a positive 11 give you positive 33. But if you multiply a negative 3 and a negative 11, doesn't that give you a positive 33 as well? Right? Well, what about 33 and 1? Well, 33 times 1 is 33. Negative 33 times negative 1 is positive 33 as well. But we are looking for the set of numbers that will add to negative 14. So there's only one set of numbers that will do this. Negative 3 and negative 11, those are the two integers we're looking for. Negative 3, negative 11, because they multiply to positive 33, but add, add to negative 14. Negative 3 plus negative 11 is negative 14. Look at this one. X squared minus 17x plus 20. This one is similar because you know the leading coefficient is 1, so we can start with our x and x. Look at positive 20. What two numbers multiply to positive 20 but add to negative 17? Positive 20 but add to negative 17. Actually, none do, because I wrote the problem incorrectly. The problem should read 70. X squared minus 17x plus 70. Y'all not getting no extra points from me on this one. I caught my own mistake. Ha ha ha. So x squared minus 17x plus 70. All right. So what two numbers multiply to 70 and add to negative 17? Think about all the ways you can get 70. The first thing that jumps out in my mind, other than 70 and 1, but 70 and 1 don't make sense because there's no way I can add those two together to get a negative 17. But I'm thinking 7 and 10. Okay, but positive 7 and positive 10 would give you a 70, but adding them together will not give you a negative 17. So we have to go with negative 7 and negative 10 because those are the factors that you multiply to get positive 70 and add to get negative 17. Let's look at a few more. X squared plus 5x minus 36. Prayerfully, I wrote this one correctly. X squared has a leading coefficient of 1. That's important that you recognize that because in the next section we're going to have them that don't have a leading coefficient of 1. And there's a different method that we're going to use for that. X squared plus 5x minus 36. So we know we have an x and an x. We have a what? We look for two numbers that multiply to negative 36 but add to a positive 5. Okay, now the way you have to think about this one, when two numbers multiply to negative 36, what do you know that has to be true about those two numbers? When you multiply to get a negative number, what has to be true? One of the numbers has to be positive and one of them has to be negative. So when you look at negative 36, you know that you're looking for two factors that are of different sign. One of them has to be positive, one of them has to be negative. However, they have to add to a positive 5. So the positive number that you choose has to have a bigger absolute value than the negative because the positive has to kind of outweigh the negative in the middle. So what two numbers multiply some kind of way to negative 36 but add to 5? Well, what numbers multiply to 36? Well, we have 36 and 1, 2 and 18. But can you add 2 and 18 either positive, negative, or any kind of way to get a 5? We're looking for a positive 5. No. What about 6 and 6? 6 and 6 multiply to 36, but that won't add any kind of way to give you a 5. What about 9 and 4? 9 times 4 is 36, right? But what if I have a negative 9 and a positive 4? That multiplies to negative 36, right? But does it add to a positive 5? No, it doesn't. It adds to a negative 5. So what if we make the 9 positive and the 4 negative? Multiply those two together, you get negative 36. Add those two together, you get positive 5. So those are the two factors we're looking for. Positive 9, negative 4. And again, it doesn't matter what order you put them in because of the commutative property. Now look at the next one. X squared plus 5x minus 14. The leading coefficient is 1, so we begin our factoring. We know that we have x and x. Now I'm looking for two numbers that multiply to negative 14. So that means they have to have different signs, but they have to add to a positive 5. Positive 5. So the only way we can get a negative 14 and a positive 5, let's see, we can get a 7 times a negative 2. That will give you a negative 14 when multiplying and a positive 5 when adding. So we need 7 to be positive, 2 to be negative. And you have just factored that trinomial. I would like you to try these before I do them, so you can pause the video and try this one. Q squared minus 3q minus 40. We know that we have q and q. And what else? We need two numbers to multiply to negative 40, but add to a negative 3. So what two numbers multiply to a negative 40? What do we know that must be true? That the numbers have to have different signs. So one has to be positive, one has to be negative, and they have to add up to a negative 3. So think about some factors of 40. How can you multiply to get 40? 10 and 4? Well, does that 10 and 4 add up any kind of way, positive and negative, to give you a 3? No. But if you look at 2 and 20, will that add up to a 3 any kind of way? No. But 8 and 5 will. If you look at 8 times 5, isn't that 40? And the difference between 8 and 5 is 3. Well, let's work on the signs. Which one has to have the negative sign? Negative 8, positive 5, multiply together give you negative 40, and add together to give you negative 3. So those are our two factors. Our two factors: negative 8, positive 5. Let's look at this one. Look at y squared plus 6y plus 15. Is the leading coefficient 1? Yes, so we begin our factoring. We have y times y. Now, what two numbers multiply to 15? That's the question. What two numbers multiply to 15 and add to 6? What two numbers multiply to 16 and add to 6? All right, 15 and 1. 15 times 1 is 15, but will 15 added to 1 give you 6? No. What other way can we get 15? Negative 15, negative 1, will that add up to a 6? Nope. 3 times 5, will that add up to 6? 3 and 5, nope. Negative 3, negative 5, will that add up to 6? No. Well, guess what? There is no such set of factors that multiplies to 15 and adds to 6. So what do we call something that cannot be factored? For instance, we can't factor 5 into anything but 1 and 5. We can't factor 7 into anything but 1 and 7. We can't factor 11 into anything but 1 and 11. What do we call those numbers that we can't factor into anything but itself and 1? We call them prime. And that's what we call this trinomial. We say that it's prime, which means we can't factor it using the methods that we've learned so far. And that will be the answer. Okay? Now, you're going to come across some that are prime. When you have your tests on this, just because you can't figure out how to factor it doesn't mean it's prime. So don't go on my test writing prime all over the place, because I'm telling you, I don't put that many prime problems on there. Okay, so let's look at the next one. A squared minus 13ab plus 30b squared. Is the leading coefficient 1? For the a, yes. So we can start our factoring. We know the beginning term has an a and an a. Now, what do we notice about the last term? It has a b squared. And how do you think we would get a b squared? By multiplying a b times a b, right? So one thing we do know is our last term has to have a b attached to it some kind of way. So we know the first term has an a in each one of our binomials. The second term has a b, but now we have to work with the numbers to figure out what happens with the numerical factors. Now we look at 30. What two numbers multiply to positive 30, and add to negative 13? They have to multiply to positive 30 and add to negative 13. It's a bunch of numbers that you can multiply to get positive 30, but only one set of numbers will add to negative 13. If you have to make a list, make a list. Will 2 and 15 do it? Well, remember, because it's multiplying to a positive 30, okay? Multiplied to a positive 30, that means both numbers have to either be positive or both of them have to be negative when you multiply. You have to multiply it to get a positive 30. The only way you can multiply to get a positive is if both numbers are the same. Well, or the same sign. Well, if you have a 2 and a 15, the only way you can do that to get negative 13 is if the 15 is negative. But we can't have a negative 15 here because both numbers have to have the same sign. So 2 and 15 don't work. The only two numbers that work are negative 3 and negative 10 because they multiply to positive 30 and add to negative 13. There's never going to be more than one way to factor it. So you have to choose your numbers correctly, and you need to check when you check with multiplication to make sure that it's factored correctly. Go back and FOIL them to make sure you got the right thing. Now let's look at this one. X squared plus 7xy plus 12y squared. The leading coefficient is 1. The last term has a y squared in it, so we know our second term in each binomial will have a y. Now we look at 12 and 7. Would two numbers multiply to positive 12 but add to a positive 7? That should be easy. That should be 3 and 4, both positive. Right? Both positive. So x plus 3y times x plus 4y multiplies to give you that trinomial. Look at the one at the top here. We have 30 minus 31r plus r squared. What do you notice about this? Number one, is not in descending order, so we want to rewrite it in descending order before we factor it. R squared minus 31r plus 30. Okay, now look at your leading coefficient. Is it 1? Yes. So we know it's R. Now, would two numbers multiply to a positive 30 but add to a negative 31? Well, the positive 30 tells you that both numbers have to be either negative or positive when you multiply. But if they're both positive, they can't add to a negative 31. So you know both of your numbers have to be negative. Negative what? Negative 30 and negative 1 will multiply to a positive 30 but add to a negative 31. Now the next couple of examples we have to look at, and we're going to ask, can we factor out a GCF? Honestly, factoring out the GCF is always the first thing you do if there is one. Now let's look at the polynomial here. X cubed plus 3x squared minus 4x. Well, can't we factor out an x? They all have at least one x in there. And after we do that, we're left with x squared plus 3x minus 4. Okay, now we can further factor the trinomial, perhaps. Let's try it. Now the trinomial has a leading coefficient of 1. So we go x and x. Now I want two numbers that multiply to negative 4 and add to positive 3. Well, if they multiply to negative 4, That's a negative. They have to have different signs. One has to be positive, one has to be negative, but they have to add to a positive 3. So what two numbers multiply to negative 4 but add to positive 3? So that would be a positive 4 and a negative 1. And that is the factored form. Next example, factor out the GCF. Is there one? Yes, there's a 4 that can be factored out, and it leaves us x squared minus 6x plus 9. Now, if you remember, we talked about perfect square trinomials last section. Perfect square trinomials come from squaring a binomial. This one is starting to look like one. Let's factor this. The leading coefficient is 1, so we know we have x's. What two numbers multiply to 9 and add to negative 6? It's negative 3 and negative 3. Wow, but negative 3, x minus 3 and x minus 3 are the same thing. So what we do is we write this as 4 times x minus 3 squared. Remember, when you square a binomial, you get this pattern. You have to remember the pattern. I won't illustrate it here, but this is something we talked about, and we'll touch on it a little bit later in this chapter. Here, let's factor out a GCF. Look at it closely. We have 5x to the 5th minus 25x to the 4th minus 30x to the 3rd. Now, what's the GCF? Not just 5. There's more common to them other than just 5. 5 what? 5x what? To the 3rd. They all have an x to the 3rd in there somewhere. Okay? Now, once we factor out 5x to the 3rd, then we have x squared minus 5x minus 6. Okay? Now we can go ahead and, it's a funny looking x. Now we can go ahead and factor that further. So we have 5x to the 3rd times, we have x and x. What two numbers multiply now to negative 6 and add to negative 5? Negative 6 and add to negative 5. Well, if it multiplies to negative 6, then the two numbers have to be different signs. So one's positive, one's negative. And they have to add to a negative 5. So what do we have? Negative 6, positive 1. They multiply to a negative 6, but add to a negative 5. So that's what we have there. That is the factored form. Notice you have 3 factors. 5x cubed times x minus 3. 6 times x plus 1. 3 different factors. What about the next one? We have what can be factored out. 3y squared. Once we factor it out, we're left with a y squared minus 6y minus 7. Can we go further with it? Y and y. And what else? What two numbers multiply to negative 7 and add to negative 6? That would be a negative 7 and a positive 1, because they multiply to a negative 7 and add to a negative 6. So check this out in your homework. Practice. If you do 15 or 20 of these, you'll be good. Just you have to work on understanding what signs go where, and this is where it helps to know your timetables and to understand how you add and multiply integers. So good luck. I'll see you in class.